Well, hey guys, this is Mr. Roden. Welcome to the 9.1 through 9.3 video reteach. So if you didn't do well on this quiz, then you can watch my video here and you can make corrections on your paper and then show this paper to either myself, if I'm your math teacher, or Mrs. Peterson, if she's your math teacher, or Mr. Sansoni, and he's your math teacher, and you can just correct the ones you missed. I would always write a sentence why you missed it. I think the best thing to do is write down the answers to all the problems and just kind of redo the whole quiz and then show that work to your teacher, and then they will give you a hard copy of the version 2 during your 7th period to retake it so you can get your grade up. Hopefully you didn't need to do this, but if you do, let's take a look at how you do these problems. Now, one thing I want to say is they're probably out of order from what you see on your test because we mix it up. So each student is going to have a different order in how you see these problems. So you might have to fast forward me and find the ones that you missed because it probably doesn't follow the same order as me. But let's take a look. All right, so go ahead and find this problem. We'll call this number 1 right here on your tests. So you might want to pause me and go find this on your test somewhere. All right, so what are we doing here? So it says that we want to simplify the expressions. So I kind of have the answers written out here, but I just want to kind of talk ourselves through it. So the first thing is, you notice we have powers of 2 everywhere. And what I like to do is I always like to, when I'm dividing with that fraction bar, I want to divide 1 power on top with 1 power on the bottom. But right now, if you notice here, guys, we have 2 powers on top and we have 2 powers on the bottom. And I don't want that. I want 1 power on top and 1 power on the bottom. So what I'm going to do is I'm going to use my power rule to simplify this numerator, these yellow ones. And what do? Well, we copy the base, the common base, and then we just add. When you have the same power times the same power base, you just add. So 14 plus 6 is 20. Likewise, on the bottom, 2 to the 8th times 2 to the 3rd is 2 to the 8 plus 3, which is 2 to the 11th. So now notice, guys, I have 1 power on top and 1 power on the bottom with the same base. And then I can use my divisibility rule. And when you divide, remember, a fraction bar means divide. When you divide 2 powers, you copy the base and subtract the top exponent and the bottom exponent. And so 20 minus 11 is 9. So you get 2 to the 9th. So that would be your answer right there. Okay. So hopefully if you missed that, correct it and show us what you got. All right. Next problem. All right. Go ahead and find this one on your test. It's 5 to the 8th over 5 to the 3rd. This is just simply a division rule, or something we're just going to subtract. Top exponent minus bottom exponent. 8 minus 3 is 5. So it's going to be 5 to the 5th. Notice it's not just going to be 5. It's going to be 5 to the 5th power. Piece of cake. That's easy. Hopefully you guys all got that. All right. This one, piece of cake, guys. So remember, when we're writing as an exponent, we copy the base. How many times is the negative 6 being multiplied? Well, 1, 2, 3, 4 times. So we want something with a negative 6 to the 4th. So it's either going to be one of these last 2 times. They are using an x for times, which is fine. Sometimes we'll use an x for times. And how many x's do we have? We have 1, 2, 3, 4 x's. So it's going to be negative 6 to the 4th, x to the 4th. So it's going to be this one right here. That's a piece of cake. That's all you have to do. All right. On this one right here, we're going to use our Pemdas rules. Okay. Parentheses first, exponents, multiplication, division, add, subtract last. So on this step right here, you can see that the first thing I did was I did this 3 to the 2nd power right here because I want to work within my parentheses, and within those parentheses, exponents has to come first. Well, what's 3 to the 2nd power? 3 to the 2nd power is equal to 3 times 3, which equals 9. So I'm going to replace that 3 to the 2nd power with a 9. Okay, the next thing is I did exponents within the parentheses. Now I have to do multiplication and division. So I see I have 8 divided by 4. Well, 8 divided by 4 is 2. So now I have 6 plus parentheses 9 times 2. Now I have to multiply. I need to finish those parentheses off, people. Finish those off. 9 times 2 is 18. And then I don't have any more math to do within the parentheses. So now I just take 6 plus 18, and that's going to give me 24. So that's what you wanted to type into the blank right there. Okay? Excellent. All right, the next one. Evaluate. Remember, evaluate means do all the math. Okay, so let's see here. So the first thing, again, we're doing PEMDAS again. So the first thing we want to do is we want to take care of our 2 to the third power, because we want to deal our exponents inside of our parentheses. So let's remember, 2 to the third power is equal to 2 times 2 times 2. So instead of a 2 to the third power, this 2 to the third power right here, 2 to the third power is equal to 8. So I'm going to put an 8 right here. See that? All right, now the next thing I'm going to do is I'm going to do 4 to the second power. Well, 4 to the second power is 4 times 4, which is 16. So I'm going to replace 4 to the second power with 16. All right, cool. Now I'm going to, within my parentheses, I need to do division and multiplication. Well, I have 8 minus 5 times 16. I've got to multiply before I subtract or add. So 5 times 16 is 80. So this little part right here is now equal to 80. I'm going to substitute 80 in for 5 times 16. And then I do the math. 8 minus 80. Now remember, when you have think about it this way. When you're taking a negative and a positive number and you're adding or subtracting them. Well, 8 is positive, 80 is negative, and when they're on different sides of the addition, subtractions, the sign table, we're going to subtract and keep the bigger sign. Well, 80 minus 80 minus 8 is equal to 72. And since the negative is bigger, it's going to be equal to negative 72. So that's how I got this negative 72 right here. All right. And then the last thing we want to do is we want to do a positive times the negative. And remember, our note here is a positive times a negative is a negative. So 3 times 72 is 216. And I forgot to put my negative, and that means it's going to be negative 216, okay? Because a positive times a negative is a negative. All right, number 6. All right, now the key here is to remember, I always tell my class that we've got some spooky ones going on here, right? Well, what's a spooky one? A spooky one is a exponent of 1 that you can't see. You just have to know it's there. So what I did is I rewrote this problem, negative 4a all raised to the third. I rewrote it as in kind of a big parentheses, negative 4 to the first times a to the first, all raised to the third. See what I did? So I just recopied it. This is the same thing, just written with the spooky ones. Now, then I'm just going to take that 3 and I'm going to multiply it, because remember, we were raising powers to powers. When you raise powers to more powers, you multiply. Well, 3 times 1 is 3, and 3 times 1 is 3 again. Now, there is a little note off to the side, because normally you could leave this as negative 4 to the third power, but in this answer right here, they actually want you to multiply it out. And I know that because negative 4 to the third power is not an option here. So it looks like I need to actually figure out what negative 4 to the third power is. Well, that's negative 4 to the third power is negative 4 times negative 4 times negative 4. Well, negative 4 times negative 4 is positive 16. And positive 16 times negative 4 is a positive times a negative is a negative, and 16 times 4 is negative 64. So our answer there is negative 64, a to the third. So it's going to be this one right here. All right. Hope that helps. Number 7. Remember, we have this one, we just have x to the 4th times x to the 6th. Remember, guys, when you have a power times a power means add the exponents. Okay, that's my little note on that one. So that's pretty simple. You just copy down the base, which is x, and then you just add the exponents. 4 plus 6 is 10. So that's a piece of cake. That's just x to the 10. You just have to know the rule on that one. No worries at all. Okay, so this one, you got to be careful here, because you can't add the 12 and the 11 because you have a base of x and a base of y on top. And you can't add the 9 and the 5 because you have a base of x and y on the bottom. So what you're going to have to do is you're going to have to do the divisibility of exponents, quotient of powers rule, I believe it is we're going to have to take care of the x's using our quotient of power or dividing exponents rules. And we're going to have to take care of the base of y's using our divisibility or quotient rules. Well, what's our rule? We copy the base and subtract the exponent. So in this case, we're going to take 12 minus 9. 12 minus 9 is 3. And then for the y's, we're going to do 11 minus 5. 11 minus 5 is 6. So our final answer should be x to the third, y to the sixth. So it's going to be that guy right there. Great. All right, number 9, same thing here. We're just using a basic quotient or dividing exponents or powers. So we just copy the base, which is negative b, and then we just subtract top from or bottom from top. So denominator from numerator. So 10 minus 2 is 8. So that should be negative 10 to the 8th power. Man, that was an easy one. You guys are going to do this easy stuff. Now here, guys, we have what do we have here? We have a power raised to another power. Well, what's the rule when you have a power raised to another power? You just simply multiply. We've kind of talked about that. So what's 10 times 2? Well, 10 times 2 is 20. So it's going to be y to the 20th. Man, that was easy. All right, so now let's do this next one. So now we want to evaluate. Well, what does evaluate mean? Evaluate means do all math. We want to do all the math here, okay? So what is 5 to the 4th power? 5 to the 4th power is 5 times 5 times 5 times 5. And what I like to do is I like to just multiply in pairs. Well, 5 times 5 is 25, and 5 times 5 is 25. So we're just multiplying 25 times 25. Now, I've memorized this because in our perfect square list we did with our Pythagorean theorem problems, 25 squared is equal to 625. So I've kind of already have that memorized in my head. If you need to do the multiplication, you can do it, but you get 625. And there's your answer. Piece of cake. All right, number 12, no problem at all. How many 5s do we have? We have a base of 1, 2, 3 5s, so that's 5 to the 3rd. And how many b's do we have? 1, 2, 3, 4, 5 b's, so b to the 5th. So it's going to be 5 to the 3rd, b to the 5th. So that's going to be right here. All right, moving on. Next problem. All right, what's the rule when you have a power times a power? You copy the common power and you add the exponents. So the common base is negative 7, and then you just add the exponent. So 4 plus 3 gives you 7. So it's going to be negative 7 to the 7th power because 4 plus 3 is 7. Piece of cake. All right, number 14 is a little interesting. So look what our goal. Our goal is always to get 9 to the 4th power. So that's the key. Got to remember, I always want to get 9 to the 4th power on this one. For some reason, they want you to always get 9 to the 4th power. Now, they're going to change what m is. They're going to change the top number. Each time, they're going to go through and they're going to change this top number, but the red number here is the number you're having to figure out. Okay, see the red numbers down here I have? Those are the numbers we're having to figure out. So if they say, okay, the top number, which is m, here's our m, is 4, and we always want to get 4. Well, what's the rule? We're going to subtract. We're going to take this top 4, and we have to what minus 4 gives you 4? Well, 0 minus 4 gives you 4. So the first one is going to be n equals 0. So you take that n equals 0 and just kind of drag it up here. So you're going to take that. You're just going to drag that 0 right here. See that? Okay, the next one, they give you an m. In this case, they tell you that m is 9. So now m is 9. Well, 9 minus what gives you 4? Well, 9 minus 5 gives you 4. So now you're going to put the 5 right here for n. The next one, they give you a 7. Well, 7 minus what gives you 4? Well, 7 minus 3 gives you 4. So you're going to put the 3 here for this one. And the last one, they give you a 10. Right here, they give you a 10. Well, 10 minus what gives you 4? Well, 10 minus 6 gives you 4. So you're going to put that one right there. You're going to drag those in there. Make sense? Awesome. All right, last one. Let's take a look at this last one here. All right, is this one true? Well, what I did is a little work off to the side. Well, 2 to the 3rd times 2 to the 4th, I used my powers times a powers rule and added them. So 3 plus 4 is 7. So instead of having a 2 to the 3rd plus 2 to the 4th, I replace that with a 2 to the 7th. And then minus, well, 2 to the 2nd raised to the 3rd. Well, that's the multiplication rule. 2 times 3, that's 2 to the 6th. So now I have 2 to the 7th minus 2 to the 6th. Now they're saying, does that equal, and there's really a spooky one on 2 to the 1st. Well, no, that's completely false. Okay, we never have had a rule where we take the same base minus the same base power and actually do anything with the powers. What you would have to do if you wanted to figure this out is you'd have to figure out what 2 to the 7th is. 2 to the 7th is 2 times 2 times 7 times. And 2 to the 6th is 2 times 2 times 2, 6 times. So that's going to give you 28, and the other one's going to give you 64, and 28 minus 64 gives you 64. So that's what you should have put in. You should have said false and 64. And that's it. That's all this quiz was. It was 15 problems. It shouldn't have been too bad. If you did poorly on it, hopefully this helps you and you can retake with your math teacher as soon as you're ready to go. All right, guys. We'll see you later and have a good day. See you later. Bye.